Welcome. Today we will be discussing about one polygon clipping algorithm called Sutherland Hodgheman polygon clipping algorithm. Let me share my screen of my class handout. This already I have uploaded into Google Drive. So today we will be discussing about the Sutherland Hodgheman polygon clipping algorithm. The basic objective of this algorithm is to find out the visible region of a polygon with respect to a clipping polygon. That means here the clipping window also can be a polygon and the subject also can be a polygon. So here the task is to find out the visible portion of a polygon within a clipping polygon. Is it clear? So the class handout is already given to you. Just go through it in the Google Classroom. And now I'll be discussing about main working principle of it. The theory portion is already given as a class note. Now here, let's consider this is my clipping window. Okay, this is my clipping window, and with respect to this clipping window, actually this algorithm works as follows. The figure though look like a rectangular clipping window, but it may be a polygonal window also. So hardly matter. A clipping window can be of any shape. Idea of this working principle of this algorithm is as follows. First, it checks with respect to one edge of the clipping polygon, it checks whether the subject polygon is outside or inside. That means one edge of a subject polygon, I repeat, one edge of a subject polygon will be checked with respect to one edge of the clipping polygon. That means, so with respect to a polygon, suppose this is my let us have a figure. Suppose this is my clipping polygon and this is my subject polygon, ABC. ABC is a subject polygon. It is in fact, it is a triangle. Triangle is also a kind of polygon. Okay. Now, our aim is to determine the visible portion of this clipping polygon ABC within this clipping window. Okay, clipping window is also can be a polygon. Now, idea of this algorithm or working principle of this algorithm is as follows. So it will determine with respect to each edge of the clipping polygon, it will determine the every single edge of the subject polygon. That means, so if we consider the edge AB means we will be considering the edge in directed manner. Means if we are starting, since it is a polygon, so if we start from A and if we decide that we will proceed towards B, so the edge will be A to AB, A to B, not B to A. So AB is a vector. So it's a directed edge. It's a directed edge. So this directed edge with respect to one edge of the clipping window will be checked whether that edge of the subject polygon, here in this case ABC is the subject polygon, is coming from outside to inside the polygon or not. Let's consider, suppose this is my clipping window means the one edge of the subject polygon is this. One edge, this is the, let's say, bottom edge. With respect to this bottom edge, whether this edge incoming, I mean the edge of the subject polygon AB is coming from outside to inside, or inside to inside, or inside to outside, or inside outside to outside. So is it, are you getting my point? So first the algorithm will check whether a directed edge of the subject polygon with respect to an edge of the clipping polygon is coming from inside to outside, or going from inside to outside, or coming from outside to inside, or it is of the category inside to inside, or it is of the category outside to outside. So there can be four possibilities of the edges of the subject polygon with respect to an edge of the clipping polygon. So what are the possibilities? One possibility is that if the directed edge is coming from outside to inside, so that means the category of this will satisfy the category of out to in category. Means the starting vertex of the subject polygon, so, the edge of the subject polygon, the starting vertex is in the outside, and it is the end vertex of that particular edge of the subject polygon is inside the polygon. So then that means that will satisfy the criteria of out to in. Similarly, it can be, suppose if you consider the edge from B to C, then it will be from inside to outside. The edge is going from inside to outside, isn't it? So if you consider the edge C to A with respect to this bottom edge of the clipping window, it is of the category out to out. So there are four possibilities actually, which I have summarized here as case A, case B, case C, and case D. So case A is representing out to in category. Out to in means, out to in category indicates that whether an edge of the subject polygon with respect to an edge of the clipping polygon is coming from outside to inside the clipping polygon or not. Second category can be, case B can be inside to inside, means the starting point of the edges of the edge of the subject polygon with respect to an edge of the clipping polygon is fulfilling the category inside to inside. That means both the endpoints of the edge, directed edge of the subject polygon is falling within the clipping window. That satisfies the inside to inside category. The third category, case C, is inside to outside category. That means here in this figure, you can consider that B to C edge. The B edge, the starting vertex of the edge is B, which is lying inside the clipping window with respect to, let's say, the left clipper, with respect to this clipping edge of the clipping polygon. So B to C edge is going from inside to outside. That is satisfying the category C, that is inside to outside. Then another category could be the outside to outside. That means like this. Let's say A to C. Okay. With respect to this bottom clipper, C to A edge is falling outside to outside. So if we see the visualization of these cases, we can find this sort of diagrams. So case A is representing the edge of the subject polygon B1, B1, B2, means the edge is from B1 towards B2, is coming from outside to inside. So this is representing the case A, that is outside to inside category with respect to this clipping edge. left sider clipper of this subject of this clipping polygon. Case B is the, with respect to this clipping window, edge of the clipping polygon, the edge of the subject polygon V1 to V2 is satisfying the category in category. Means the starting vertex is also inside the polygon and the ending vertex is also within the clipping window. So this is satisfying the case B. Case C is the starting vertex of the subject polygon with respect to the clipping edge of the clipping polygon is going from inside to outside. So V1 to V2. Here V1 is set. V1 is residing in the inside and V2 is residing outside the clipping polygon. And another category can be V1 to V2. That means outside to outside. So here, with respect to this, let's say top edge of the clipping polygon, the edge V1 to V2 is lying out, is satisfying the category outside to outside. Now, with respect to all these categories, what should be the output? So when we will be processing these edges one by one with respect to each clipping edge of the clipping polygon, so we'll be getting this following output. So for case A, which is representing the out to in category for the edge of subject polygon with respect to an edge of clipping polygon, the output will be the intersecting point of the clipping edge with respect to that clipping edge of the clipping polygon. The intersecting point, let's say it is V1 dash. So in the output list, the vertex will, this following vertex will be stored. V1 dash and V2 dash. V2 will be stored. So in the output list, V1 dash and V2 will be stored for the category out to in category. Similarly, for case B, which is representing the in to in category, in the output list, the final vertex will be stored. V2 will be stored. Okay. So likewise, for the third case, case C, into out category, say for this is the edge of the subject polygon V1 to V2, the output will be the intersecting point of the subject polygon with respect to the clipping edge of the clipping polygon. So the intersecting point is, let's say, V1 dash. So the output will, in the output, V1 dash will be stored. Now for the case D, where the out to out category with respect to a clipping edge, the subject polygon edge V1 to V2, if it is satisfying the out to out category, then in the output nothing will be stored. It will be empty. So these are the following types of the edges of a subject polygon with respect to a clipping edge of a clipping polygon, and their corresponding vertices is already discussed as I stated earlier. Is it clear? Is it clear? Now we'll be discussing about the. Now I'll be discussing about the one example. It will be more clear. Okay. Before going to the example, let's discuss about the algorithmic steps of the Sutherland Hodgheman algorithm. Step one, in the first step, read the coordinates of the vertices of the subject polygon and the clipping polygon. Okay, so we will scan the coordinates of the vertices of the subject polygon and the clipping polygon. Then in the second step, consider an edge of the clipping window and compose the vertices of each edge of the subject polygon with respect to the clipping polygon and record the intersection. record the intersection, and in the third step, store the new intersection point and use it in the new list of vertices as cases discussed in the discussed previously. Now in step 4, perform the step 2 and step 3 for the remaining edges of the clipping polygon. Okay, for all the clipping polygon, we will be doing the same procedure. Finally, we will be getting the clipped polygon with respect to the clipping window. So now let's consider this example, that consider a source polygon ABC as shown in figure below. Clip this polygon using the Sutherland Hodgheman polygon clipping algorithm against the rectangular window this, okay, and show the resulting visible polygon. Okay, now let's see how we will solve this. Is this visible to you all? As I mentioned, so this is the clipping window, clipping polygon, right? This rectangular clipping polygon window is given to us. Now with respect to this clipping polygon, first we will process with respect to the left edge. What is the left edge? You just consult the previous figure. Left edge is this one, right? With respect to this left edge, if we consider the edge, let's say AB, if we consider the AB edge, with respect to this clipping window, clipping edge. So what is the clipping edge? This is my clipping edge, okay? This is my clipping edge, as you can see here. Now, if you extend this clipping edge of the clipping polygon, so you will get this figure. Now, with respect to this clipping edge, as I have drawn just now, the edge AB, which type it is satisfying, which type it is following? This AB edge, can anybody answer? With respect to this clipping edge, left clipper, this is called the left clipper. AB is falling inside the clipping region. This is the polygon, right? This is the polygon. This area is coming under the polygon, and this is the edge. So with respect to the edge, for this polygon, this subject polygon edge AB is satisfying the in category, inside to inside category, isn't it? Because complete right hand side portion is inside the polygon, right? Complete right hand side portion. So with respect to this clipper, with respect to this left clipper, the complete right hand side portion is falling within the clipping window. So therefore, with respect to this clipping edge of the subject polygon edge A to B is satisfying in to in category. And if it is satisfying the in to in category, so what will be the output? For the in to in category, you can see in to in category, the end vertex will only be stored in the output. End vertex is V2 here, right? So similarly here, for the edge AB, which edge will be stored in the output? The end vertex is B here, right? So B will be stored. So for the processing edge AB of the subject polygon with respect to the left clipper is satisfying the in to in category, as you can see here, written here, and therefore in the output list only B will be stored. Is it clear? Please respond. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Why it is in to in category? Because the edge is what edge I have considered. This is the left clipper edge, and with respect to that left clipper edge, the everything right of that clipping edge is falling in the falling inside the clipping window. Therefore, the edge A to B, both the vertex is lying inside the clipping polygon. Therefore, it is satisfying the in-to-in category. The edge, processing edge of the subject polygon AB, A to B, is satisfying the in-to-in category, and therefore in the output B will be stored as per our theory. In the theory, as we have discussed, for case B, in-to-in category, the final vertex B2 only will be stored. Okay, fine. I hope it is clear. Now, with respect to the same clipping edge, left clipper edge, what will be the next edge to be processed? Already we have started processing the polygon, subject polygon ABC, starting from A to B. Then what should we process? We have started from A and we have reached to B. Then next we have to process from B to C, right? So B to C. So next edge to be processed is B to C. For B to C, which category it is falling? B to C with respect to this clipping edge, which category it is falling? Which category is this falling?
No.
It is falling from, it is going from inside to outside. It is going from inside because all the right hand side portion of this clip with respect to this clipping edge is inside the polygon. So B is falling inside the polygon, but C is falling outside the polygon. Is it clear? Is it correct? Is it clear?
Yes, sir.
Yes, sir.
Okay, so B to C is falling the category inside to outside. Therefore, just check what will be the output for in to out category. For in to out category, it is coming under case C. The output will be the intersecting point of the intersecting point with respect to the edge, right? With respect to the clipping edge. So it will be V1 dash. V1 is the starting point, so that will be V1 dash. Similarly here, so what will be the output for B to C edge? B dash. This will be the intersecting point, isn't it?
Yes.
In the similar way, so B dash is stored, isn't it? Is it clear? Just go back to the previous one. For in to out category, case C, what is the output? For V1 to V2, the intersecting point is V1 dash, means starting points, you just make a dash over it. Okay, starting point vertex and dash over it. Following the similar way, the starting point here is B. So the intersecting point will be B dash and that will be stored in the output. So therefore, for the processing edge BC of the subject polygon with respect to the left clipping edge of the clipping polygon, the output will be only B dashed. Okay. Now, what edge we have processed? We have reached to C point, right? Starting from B to C. Now we have to go back from C to A because we are here in C. Now we have to process the C to A edge with respect to this clipping edge. Now, with respect to this clipping edge C to A, the edge CA, C to A is actually satisfying the out to in category because with respect to this clipping edge, the everything in the left hand side portion is falling outside the clipping window. So therefore, C is falling outside the window. Is it correct? Is it clear? So C to A is satisfying the out to in category. C to A is satisfying the out to in category. Therefore, let's see what is the results of the out to in category. For out to in category, the intersecting point of V1 with respect to the clipping edge will be stored as V1 dash and the final vertex V2. Similarly, for this edge C to A, the intersecting point C dash will be stored along with A. So let's see that in that what we have stored. Yes, C dash A is stored. Is it clear? Hello? Anyway, I hope it is clear, though I am not able to hear you all. Okay. Now, the processing of the left clipper is over. Now, what we need to process with respect to the right clipper. That means, after the left clipper, whatever polygon we are left out. Whatever polygon is with us, that should be processed further with respect to the another edge. So what is the next edge to be processed? With respect to the right clipper, we will process, and we will process the output of the previous step. The output of the previous step is B, B dash, C dash A. So that means B, B dash, C dash A. This clipping region is now left out. After the left clipper is applied, we are having with us the B, B dash, C dash and A region as a visible region with respect to the left clipper. So whenever we will apply the left clipper in this ABC polygon, we will be having this output B, B dash, C dash A. Okay. Now this output will be acting as the input of the next round. Next round is with respect to the another edge of the clipping region, clipping polygon. So next edge we are considering here is right clipper. So this is the right clipping window. So with respect to this right clipping window, right clipping edge, with respect to this right clipping edge, so B, B dash, C dash A. So we will start from B, B dash because we have to go in order. So we have got the B, B dash, then C dash A. So we will be processing the edge B, B dash first with respect to this right clipping edge. So we are now processing this edge with respect to this edge. Okay. With respect to this edge, whatever is in the left hand side portion of this edge, right side edge, will be inside the clipping window. So now with respect to this edge, right side clipping edge, B, B dash is falling into in category. So for into in category, as I have already mentioned, the final vertex only will be stored as the output. So for if you forgot, just consult the previous theory. So for into in category, only the final vertex will be stored in the output list B2. So similar way, we'll be storing the final vertex B dash. Now next will be, we have reached from B to B dash. Okay. Now what we need to process? We need to process. We have already reached to B dash. Now we will be processing for the edge, input edge B dash, C dash. For the B dash, C dash edge, with respect to this right clipping, edge of the clipping polygon, this B dash, C dash is also falling or satisfying the in category. So therefore, in the output, C dash only will be stored. That means the final vertex will be stored in the output. Next processing edge will be C dash A with respect to this right clipper. So for the C dash A also is satisfying the in category. Therefore, in the output only A will be stored. So we reach to A, but we have started from B. So we have to go from A to B. So next edge will be A to B to process with respect to the right clipper. So if we process the right clipping edge A to B, so we get, it is also satisfying the in category, means inside to inside category. So therefore, the output will be the final vertex, that is B. So finally, with respect to applying the right clipping edge or right clipper, we are getting this sort of output, that B dash, C dash, A and B. So now we are having with us this B, B dash, C dash, A as the output obtained from applying the right clipper. Now we will be applying bottom clipper. So bottom clipper, let's say this is the bottom clipper. Now bottom clipper will be applied on the output of the previous step. What is the output? Output is B dash, C dash. As you can see here, the output is B dash, C dash, A and B. That will be applied on the with respect to the bottom clipper. So what is the bottom clipper here? Bottom clipper is, let me draw. Here I have already drawn it. Again, I am showing it. This is the bottom clipper edge with respect to the subject polygon. Now, with respect to this bottom clipper, everything falling upside of this line, bottom line, will be inside the clipping window, and everything down the line will be outside the clipping window. So therefore, as you can see, this B, B dash, C dash, A needs to be processed. Now, first edge to be processed is B dash, C dash. Why? Because B dash and C dash point we got first from the previous step. So B dash, C dash. What is that? B dash, C dash. B dash to C dash. So B dash to C dash is here. So if you, so what category it is satisfying? B dash to C dash edge with respect to this edge, with respect to this bottom edge, B dash C dash is falling from inside to outside category. So inside to outside category, if it is B dash C dash, B dash C dash is following the inside to outside category. And for the inside to outside category, just see the intersecting point of the intersecting point only will be stored as the first vertex dashed. Okay, so B1 dashed. Similar way, the processing edge is B dash to C dash. So the intersecting point will be somewhere here, that is here. So make a dash over it. B dash was already there. So again, making a dash, we will get B double dash. So this is the B double dash point. Okay. Now in the output, so we are getting the B double dash. Now processing edge will be C dash to A, because we have started from B dash, we reached to C dash. Now we have to process from C dash to A. To process C dash to A, as you can see, with respect to this bottom edge, the C dash to A point, both are lying outside category, outside. So therefore, C dash to A edge is satisfying the C dash to A edge is following the out to out category. So just a small correction, it should be out to out. Okay, sorry, it's a typing mistake is there. Okay, just correct it. Just a typing mistake is there. C dash A is falling out to out category with respect to this bottom clipper. So in the output list, nothing will be stored. That is phi. As you can see here from the theory, that if it is a out to out category, then nothing will be stored. As you can see, out to out category, phi will be stored. Okay, so as you can see here, out to out category, for out to out category. Now going to the next out to out category, phi is stored. Now which edge to process? We have already reached to point A, vertex A. Now we have to go back to the original point B, where from we have started with. So we will process next AB. AB with respect to this bottom clipper is satisfying the out to in category, because it is lying outside the clipping window and it is going inside the clipping window with respect to this bottom clipper line. So for the out to in category, the result will be the intersecting point and the final vertex. As you can see here, for the out to in category, the intersecting point with the dashed with the first point and the final point will be stored as the output. So for the out to in category, for this processing edge AB, we will be getting the output A dash B. Okay, so this will be the intersecting point A dash. Okay, now what will be the next point to process? We have reached to point B. Now from which point we have started with? We have started with started from the point B dash. So we have to reach to B dash point. We have reached to point B. So next edge to process is B to B dash. So for B to B dash point, with respect to this clipping bottom clipper edge, this B to B dash edge is falling falling in the in to in category, or it is satisfying the in to in category. So for the in to in category, the output will be the final vertex, that is the B dash vertex or in vertex. So B dash. So by applying the bottom clipper, we are getting the output as B double dashed phi A dashed B dash. That means we are getting B double dashed, then we are getting A dashed vertex, then we are getting B, then we are getting B dash. So this region we are getting with respect to this bottom clipper. Next, what we need to process, whatever output we are presently having, on top of that we have to apply the top clipper, top edge. Okay, because that is only the that is only left out. That clipping edge is not yet applied, so that we will apply on the output of the previous step. So we after applying the bottom clipper, we are having the output as a dashed b double dashed, a dashed, b, and b dashed. This polygon we are having. Now with that, on top of that, we will be applying the top clipper. Now with respect to that top clipper, let me draw the top clipper. We have shown it in the figure. Again, I am showing it here with the. Okay. With top clipper, we what edges to process? B dash to then A dash, because in the order in which we got the vertex, in that same order we have to process the edge in the next round. So B dash, A dash will should be processed. So B double dash, A dash should be processed. And with respect to this top clipper, everything below is inside and everything above is outside. So B double dash, A dash is satisfying the in-to-in category. Both the vertices are falling inside the clipping window. So therefore it is satisfying the in-to-in category. Therefore the output will be the final vertex, that is the A dash. So in the output, A dash is stored. Then we'll process we have reached to A dash. Then we have to process we have to process A dash to B in the same manner what edges we got. So A dash B is also falling the category in-to-in. So therefore we'll get the final vertex B as the output B. So then we'll process the B to B dash. So by processing B to B dash, also we get, with respect to the top clipper, it is also satisfying the in-to-in category. Therefore the output, in the output, B dash will be stored. I am left only less than 1 minute. So you please again log in with the same user ID and password. Okay, in the next meeting. Okay, next meeting immediately after this, you will log in with the same user ID and password. I have created the recurrent meeting for this. Okay, so we'll continue. Now just before we finish up this session, next we will process B dash